Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Count the total carbon atoms. The furanose ring contains 4 carbons plus the exocyclic CH2OH group gives 5 carbons total. This makes it a pentose, 5-carbon sugar, eliminating hexose, 4, and hexulose, 3. Moving on to the next step. Identify the carbonyl type, aldose versus ketose. In the cyclic, Haworth structure shown, the ring oxygen bridges between C1 and C4 of the open chain form. The structure is a fructose-type sugar where the anomeric carbon, C2 in the open chain, bears the ring oxygen and had the ketone group before ring closure, making it a ketose, 6, specifically a 2-ketose. This rules out aldose, 5, and confirms ketose, 6. Moving on to the next step. Identify ring size. The ring is 5-membered, 4 carbons plus 1 oxygen, which is a furanose, 8, not a pyranose, 7-membered ring with 5 carbons plus 1 oxygen. And for the final step, combine the terms. The sugar is a 5-carbon ketose in furanose form, pentulose, 2 plus ketose, 6 plus furanose, 8, is equal to option A, 2, 6, 8. Why other options fail? B, 2, 6, 7, pyranose is wrong because the ring is 5-membered, not 6-membered. C, 1, 5, 8, pentose and aldose are wrong because the carbonyl was at C2, ketone, not C1, aldehyde. D is wrong because option A correctly identifies it. Therefore, the correct answer is A. Therefore, the correct answer is option A.